You've probably seen the image, right? In movies, in documentaries, this absolutely massive wall of water, hundreds of meters high, just erasing a coastline. It's terrifying, but you have to wonder, could a wave that big actually make it across an entire ocean?
So that's the big question we're tackling today. Is this just Hollywood fantasy, or is it a real-world possibility? The answer is pretty fascinating, and it gets into the physics of waves and the geology of some truly mind-blowing events. So, let's find out.
All right, so to really get our heads around this, the first thing we have to do is understand that not all tsunamis are the same. In fact, there are two totally different kinds of these waves.
And this slide really lays out the core difference. On the right, you've got your regular tsunami, like the one we saw in 2004. It's born from a huge earthquake on the seafloor. Now, the key here is its wavelength. We're talking hundreds of kilometers long. That lets it travel across whole oceans without losing much steam. But then on the left, you've got the Mega-Tsunami. This thing is born from something like a massive landslide splashing into the ocean. It starts out incredibly tall, but its wavelength is much, much shorter. And that, well, that changes everything.
Okay, so why? Why does that giant wall of water just fizzle out? It seems counterintuitive, but the answer really comes down to some pretty basic physics.
It all boils down to this concept right here, energy dispersion. The easiest way to think about it is like tossing a rock into a pond. You see those ripples? They're biggest right where the rock hit, but as they spread out, they get smaller and smaller. A mega-tsunami does the exact same thing, just on a terrifyingly massive scale.
And this right here really breaks it down for us. See, a wave's power comes from a mix of its height times its wavelength. With a mega-tsunami, you get this ridiculous height, but that short wavelength means all its energy is packed into a really small area right at the beginning. As that wave moves forward and the front spreads out, that same amount of energy has to cover a much, much bigger area. The result? The wave height drops, and it drops fast. It just can't keep that monster size over thousands of kilometers.
So it sounds like case closed, right? A mega-tsunami caused by a landslide just can't cross an ocean. Well, not so fast, because there is an exception. An event so incredibly violent, it basically rewrites the rules.
For this, we gotta go way back, 66 million years ago to be precise, the day the dinosaurs' reign ended. A rock, literally the size of a mountain, came screaming out of the sky and slammed into what is now the Yucatan Peninsula. This didn't just cause a tsunami, it triggered a global cataclysm.
Just try to process this number, 30 trillion tons. That's how much water the impact instantly vaporized and blasted out of the way. I mean, the sheer scale of that is almost impossible to imagine.
And all that displaced water created a wave that, at its start, was 1.5 kilometers high. Forget hundreds of meters, we're talking about a wave that was nearly a mile tall. It would have literally scraped the sky.
And here's the engine behind it all. The energy released was just astronomical. This wasn't some local splash. This was enough raw power to send a catastrophic wave pulsing across the entire planet.
You know, to really put this into perspective, just look at this comparison. The huge waves from the Krakatoa eruption, the devastating 2004 earthquake. I mean, they traveled for thousands of kilometers and were incredibly destructive, but they are completely dwarfed by the Chicxulub event. That asteroid is the only thing we know of that created a true mega-tsunami that went global, leaving its mark in the rock layers on totally different continents.
Okay, so an asteroid strike like that is thankfully an incredibly rare event. So what about the threats we hear about today? Let's bring this back to the present and try to separate the real science from the scary headlines.
You've probably heard about this one, the idea that a piece of the La Palma volcano in the Canary Islands could collapse into the ocean. Now, some of the first computer models of this were, frankly, terrifying. They predicted waves hundreds of meters high slamming into North and South America. But here's the thing, our science has gotten a lot better. Newer, much more sophisticated models show that while it would be absolutely devastating for the nearby islands, that old friend energy dispersion would do its job. By the time the waves crossed the Atlantic, they'd probably be less than 10 meters high. Still very dangerous for sure, but not the continent killer people once feared.
So if the Hollywood-style landslide mega-tsunami isn't the thing that's going to cross an ocean, what is the real danger we should actually be thinking about?
And this, right here, is the key takeaway. The real, proven threat that we as a species need to prepare for are these so-called ordinary tsunamis of extraordinary size. These are the ones generated by massive undersea earthquakes. They don't start a kilometer high, but their super long wavelengths let them cross entire oceans with terrifying power, just like we witnessed in 2004. This is the primary global tsunami threat. Which I think brings us to a really powerful final thought. The science pretty clearly shows a landslide megatsunami probably can't cross an ocean. But in figuring that out, we uncover a much deeper truth, that the peaceful, calm blue surface of our planet is hiding these just unimaginable reservoirs of energy, tectonic, volcanic, and sometimes cosmic. And really, understanding that power is the key to respecting our planet and being ready for its most violent moments.